All right, 7.1 is exponential growth, and generically, the equation that we look at is y equals ab to the x minus h plus k. So this is the generic equation, and with numbers in it, we'll do actually an example. We'll look at from your homework number 21. Number 21 on the homework on page 482 gives you this equation, and it asks that you graph it. All right, so a couple things we want to look at. First of all, this value here, the 3, which is the k value, this is where the asymptote is going to lie. And so if you were asked to graph this equation, the first thing that I would suggest that you do before anything else is graph the asymptote. The asymptotes are going to be horizontal asymptotes, meaning they're going to be horizontal lines, which in this case, y equals, horizontal line is y equals 3. So this graph, even before we try to plot a point, we know we have an asymptote at y equals 3. Now there's other things about this formula that we can look at that are interesting. For example, the minus 3 here. But rather than kind of get caught up in those details, what I'm going to recommend for right now is that once you graph the asymptote, is that you actually plot some points. The first point that I like to plot is the one that makes the exponent here be 0. So if we have x minus 3 up here as the exponent, if I plot at x equals 3, 3 minus 3 is 0. And so we could solve for y. 3 minus 3 is 0. 2 to the 0 is 1. Anything to the 0 is 1. 1 times 6 is 6. And 6 plus 3 is 9. So that's the first point. And I'll pick a second point. I'll pick 4. At x equals 4, we have 4 minus 1 is 3. 4 minus 3 is 1. So 2 to the first is 2. 2 times 6 is 12. 12 plus 3 is 15. Now we'll go in the other direction. I'll go down. We'll go ahead and go with x equals to 2. When I put 2 in here, now this is key. When I put 2 in here, I get 2 to the 2 minus 3, or negative 1. 2 to the negative 1 is 1/2. Okay, you have to remember the rules of negative exponents. So what we get is we get 2 to the negative 1, which is 1/2. 6 times a half is 3, and 3 plus 3 is 6. Okay, we've got 3 points here. Let's take a look at the graph. First point is 3, 9. We'll just kind of put that over here. The second point is 4, 15. That's all the way up here. We have 2, 6, which is here. And that's as far as you need to go, because as I said at the start, we have an asymptote at y equals 3. We never crossed the asymptote. If you kept plotting points, okay, for example, if we picked a point over here on the x, the negative x side, let's say x equals to negative 2. When I put negative 2 in here, I get negative 2 minus 3, which is negative 5. 2 to the negative 5 is 1 over 32. 1 over 32 times 6 plus 3 is a very small number. 6 over 32, I'm sorry, it's not a small number, it's a number that is just a smidge above y equals 3. 3 plus 6 over 32 is a little bit more than 3, a little bit less than 3 1/4. So you see, we continue to decline toward the asymptote, and no matter how far out we go to the negative x, we are never going to cross that asymptote. So here's the graph that we create from this problem. Now, after you construct the graph by plotting points, you're going to have to tell me the domain and the range. Remember, the domain are where x values are valid. And for most of these, there is no restriction on x. Okay, I can make x be negative, I can make x be 0, I can make x be positive, it doesn't matter. Most of the time, the domain is going to be all reals. The restriction is going to come on the range. The range are the y values. Because of the asymptote, we'll never go below y equals 3, meaning all of our points for y are going to be above y equals 3. So in this problem, our range is y is greater than 3. So one thing you have to be able to do with growth, plot it. You've got to be able to tell me the domain and the range. The other two things about growth is there are two formulas that we use for purposes of determining growth, whether it be money or other forms of appreciation. The two formulas I give you will be A equals P times 1 plus R to the T, or I'll give you A equals P times 1 plus R over N to the NT. Okay, this is for appreciation. Something appreciates in value. And this is for money with compound interest. If I gave you a problem that said we were going to deposit $2,500 in the bank, this is number 37, I'll do 37B here. If I said on number 37 we're going to put $2,500 in the bank, we're going to get a rate of 2.25%, and we're going to compound monthly. What you need to remember is N is the number of times per year that we compound. R is the rate. P is the initial amount. And A is the final amount. So with this problem, we plug into the formula. We get our final amount is going to be our initial amount, which is 2,500, times 1 plus the rate. The rate must be a decimal, so 2.25% is the same as, 0.225, 0.0225. Okay, that's 2.25%. The number of times per year that we compound, well, if we're compounding monthly and there's 12 months in a year, it means we're compounding 12 times. So we put 12 for N. Raised to the N and T. And in this problem, we want to see how much money we'll have in 4 years. Okay, that was the other part of problem number 37B. So it's 12 times 4 because T is 4. And then you just use your calculator and you solve this. And it turns out that at the end of 4 years, at that interest rate, okay, compounded monthly, you'll have this much money in the bank. So we'll do problems where we graph. We'll do problems where we calculate results from appreciation. Okay, good luck on the homework.